Hello. Hello everyone. My name is Umar Hayat, and I work for the core R&D team as a lead for the database development and high availability. And I hope everybody would be fine. So today's session is about the backup and recovery topic, which is quite important topic for the database industry. And I will be talking about about this a bit today. So let's get started. So the first of all, for the backup and recovery, the first question is why you need it. I mean, why we exactly need the backup, and then we can. I mean, first we need to find the problem. What is the problem? Then we will come to the solution. So normally in any database industry, for the backup, why we need it, there are multiple reasons. The first one, the most important one, is the data loss prevention. And then you have the disaster recovery. And after that, the business continuity, and then compliance, and then, of course, your peace of mind. Now, all these points, I will explain all of them in the next session, next slide. The first one is the data loss prevention. So the main aim for this data loss, this backup and recovery, is what can bad happen. The bad thing can happen is, there are so many reasons. One of the main reason is accidental deletion. All of us are human being, and of course we can, by any human error, we might be able to delete some critical data, and that would be considered as accidental deletion. Of course, if there are some disgruntled person in some organization, he can intentionally delete some data as well. But most of the time, it is unintentional error, human error, that lead to deletion of the critical data. Another reason is while you have some different kind of complex setup for the high availability or some other structure, and you might be inserting incorrect data, and maybe you are because of some excess information, you are doing some commands, SQL command or some administrative command, which you don't know, but they can result in deletion of some data. Another most common reason is the hardware failure. The physical damage in any, maybe it could be in some storage device, or it could be the whole server. It could be the whole data center that can be, can be damaged, and which will result in the data loss. Another most common reason is the software corruption. That any, let's say if you have any um, system level, operating system level issue, and it can corrupt the data files, or maybe some network or packet is corrupted, and that can result into the corruption of the database file. Or maybe it's Postgres itself that can corrupt the database. Let's say you accidentally using the wrong version of PostgreSQL, and unintentionally, which it can lead to some software corruption, and eventually it would be some data loss. And these days, the most common and major actually concern of the database industry is the cyber attacks. You can see, you can hear in the news that everywhere, all the time, the black hatters and criminals, they use different techniques, ransomware, some hacking, or advanced persistent threats, that can eventually they can delete your data, or maybe encrypt your data, or steal your data. So these whole thing, all these factors can lead to data loss. And one of the reasons for this backup and recovery is the data loss prevention. The next measure is these things maybe you can control, but let's say the disaster, the natural disaster, if there is some fire, some flood, or some earthquake, or some other natural calamities, of course, in that case, maybe not only your server or the data center, maybe the whole region can be affected by that natural disaster. And eventually, that will, lead to your database or data loss. Another common factor could be the power outage. And let's say your electricity power or backup power is failed, and then of course you cannot get enough electricity and power for the network and also for the database server that they can run normally. And eventually, that can lead to the data loss. So this is the second point, that backup and recovery, we use techniques to mitigate these disasters. Not disaster, of course, you cannot mitigate the disaster, actually, the effect of the disaster. The major, from the business point of view, you can see that, of course, every database is backing some actual business or some application. And all those critical businesses, they rely on these databases and eventually the data. And they need to have a business continuity or business contingency plan for different kind of events. And let's say whatever the reason on the natural disaster or any other data loss reason, eventually, let's say thing happen and your data is lost. The question is, how would you restore it? Okay. And you have to do it quickly to as a business contingency plan. These data losses can, of course, become the major financial loss. And using these techniques, you can reduce the even financial loss too. And of course, whenever any database crash or a server crash, you hear so many news, on the that some backend server or some data center crash. Eventually, what it leads to is some chaos, even in the public. Let's say the whole system is down, and some people, they will be using some application, and they rely on application, and some application are quite critical for communication between the people. And disruption in those kind of application and downtime can, severely affect not only the business, but daily life and the routine tasks people do. And the last one is the data integrity, that the backup and the recovery techniques and tools make sure that data is consistent and accurate all the time. Another major reason why you need backup and recovery is the compliance. Different countries, they have different regulations, and different requirements are there that you have to follow. Every company, every database, not only the database company, different businesses, they have to follow these regularity requirements. Like for example, the finance maybe have different kind of requirement like PCI DSS. Some other US company, US maybe they would have a HIPAA requirement. And probably, if I remember, in Korea, there is a requirement for the personal data safety or retention. So maybe there is no direct legal requirement for a specific database and recovery, but there is an indirect requirement that your personal data should be safe, and it should be it should be safe and recoverable for a specific number of days or number of months. So every different industry have different kind of regularity and compliance requirements, and that these backend recovery tool can help to achieve those things. And the last thing, of course, doing all those things, what it means is, is the peace of mind that not only the public, people run business, they own different companies, they work for the companies, and these kind of, data loss, and of course, they can lead to severe mental issue as well. So if you have a proper plan for backend recovery, you can mitigate those risks. And also, of course, is this, to make for the business contingency planning, this is very necessary so that the business runs smoothly. Now, to how to, I mean, like for the backend recovery, there are a few principles. Not only for this, I will come to the next slide where I explain, how different industries follow these kind of principles. So these four principles like detection, avoidance, and correction, few of these principles will affect the backup side. Some of it, the portion will affect the recovery side, and some of it would be just kind of management side. So these are the basic principles. First, you need to detect that something happened, and then you should make sure that something should not happen. And let's say somehow something actually happened. Now you need to correct it and mitigate it and recover it, recover to that situation that something bad happened. Now we need to recover that situation and to continue the business. Now, if you see these kind of the same principle are actually followed by all the industries. Let's say if you have the finance industry, there are different kind of like for example, if you consider about the fraud prevention. So you see, there is a normal check and balance of detection, which is review the activities, then update those fraudulent activities your system so that nobody can misuse them. And then if there is something happened, actually some fraud is happened, then you have to need to have the financial restitution, that you have to compensate someone to make it correct. And of course, as a result, you will analyze the situation and update your system again to avoid those kind of situation in future. Similarly, if you see the finance industry, the risk management, you monitor the fluctuation in the financial industry, and to avoid that fluctuation, you have different kind of investment strategies that you will invest in diverse portfolio to avoid fluctuation in a specific sector and a specific company. And then to make it correct, you have the contingency plan. Okay, let's say something bad happened and we are start losing something, how to correct it. Similarly, if you see the manufacturing industry, they have the quality in where they manufacture different products. For the quality control, for the detection, they have a regular inspection of the products. And to, let's say, if they find some inspection, during the inspection, they find some defect, I mean, they will implement the correction. Like if you see most of the time, the automobile industry, first, I mean, they have the internal inspection system. And if they found some issue, they can even pull back all the different cars and provide the fixes to those cars. And of course, to avoid this whole thing, they have that their own teams to do the defect analysis so that in future the similar kind of situation should not happen. Similarly, for the manufacturing of supply chain section, the supplier, you have to regularly monitor the supplier performance so that if something is bad performance is happening, they have to have, do the analysis. And if the performance is bad, how would you use the contingency plan to correct it? And of course, to avoid this kind of situation, of course, you have to monitor and update your inventory levels. Similarly, in the cyber industry, if there is a threat prevention, you have to do regular vulnerability assessment using internal or the white hat hacker or your own, testing team. And there are different system which are in place to do this kind of vulnerability assessment. And let's say something bad happened, and now you have to recover the system. Okay, maybe some ransomware or some other data is lost, you have to recover it. And to avoid these kind of situation, you should have a proper incident response plan so that you should not be in that specific situation. And of course, different companies have incident response teams that can actively monitor and try to prevent the situation which is going to happen. So this is the principle where something actually happened. What we should do, most of the companies industry do is not only react. That was the reactive approach, that something bad happened and now you have to act on it. Okay, but there is an proactive approach that you do those kind of proactive activities and put the system in place so that that situation should not be happening at all. Okay, like for example, finance system, they have the different kind of softwares or different kind of fraud detection system and models, real-time transaction monitoring, and of course they also educate the customer too, that to avoid the human error as well. So this is proactive approach, that you beforehand, when nothing is happened, you teach your system and the people that they should be aware that something bad can happen. And similarly for the risk management, the proactive approach is, before even going to actual situation, you should do the stress testing, and you should, research on research on diversifying the investment. And there are multiple different kind of assessment model that can be applied beforehand to avoid any kind of future issues. So similarly, of course, in cybersecurity, there is you can implement so much controls, security controls, like for example, firewall and IDS, like intrusion detection system. And of course, to avoid the human error, you also have to educate the employees, even in general public too. That's the job of the governments, to educate the people, common people, about these kind of security trainings. So now the question is, how would you know that something bad happened specifically? Okay, now we already see, different industry have different kind of detection methodology to check whether something bad is happened. Now, how would you check the same thing in database world, specifically in the PostgreSQL database world? Okay, now you would be showing, I mean, you might be looking at some this kind of result, like your query is returning incorrect result. Okay, and of course, if something is corrupt, and then you query the same data from a specific table, it can return invalid result. Okay, these are the pointer where you see, okay, something is bad is happening. Okay, so this, I mean, maybe the problem could be that you run some query and it goes into infinite loop, and you are just waiting for the response, and database is not responding. And this is one of the the pointer that you can see that something bad is happening and data might be correct, and it needs, of course, further investigation. Or maybe if there is a redundant system and you are getting some duplicate rows, duplicate data, that can also be a pointer that a symptom that something is bad is happening. Or maybe not only this one, this is kind of data inconsistency you can observe during some monitoring tool or some, the manual, the application user can observe. But of course, in the worst case scenario, system can crash. Okay, so your operating system or maybe just database system is crashed if you run a specific query, and those are the symptoms. Now, if you see for the database administrator, if they see different kind of log in the PostgreSQL, that it is not able to read some data file, it is not able to check the transaction, if it is not able to, in PostgreSQL database server is not able to make checkpoints. I mean, those are the things that should be monitored, and there are different systems that can monitor these kind of logs. And these are the symptoms that you can say that, some data corruption is happening and someone need to take care of it. So in PostgreSQL, there are so many ways how to take the backup. So I will explain a few of them, which are mostly internal to the database system and provided by the PG community. And let's start with the simplest one, which is like, for example, if you have what options do you have? One is that you use the built-in options like which are provided by PostgreSQL server, not PostgreSQL server, actually PostgreSQL community. Okay, it's open source tools which are available in the same package where you have the server as a utility. So, I mean, the built-in tools are like pgdump, pgdumpall, and on the physical data backups, you can use pg-based backup. Similarly, of course, you can use external tools as well. Like, I mean, you can just use just normal file copy. Of course, that's also backup, or maybe rsync or some other storage level backup option, or maybe some other third-party open source tool, or maybe even proprietary tool as well. So there are multiple options which you can use for the backups. So the first I will explain about is the pgdump. Pgdump is normally considered as the logical backup tool that you just specify a database name and you run the utility. Of course, if it is a local system, you don't need to specify, or maybe of course you can specify different connection properties like username, hostname, and port. How would actually authenticate with the database. And then, of course, if you want to dump most of the things which you want to dump, you should have the administrative privileges so that you can access the specific object that you're going to dump. And you have the flexibility. You can dump one schema only. You see in the PostgreSQL architecture, you can define multiple schema and you can divide your database into multiple schemas. And if you want to dump one schema, you can just provide the name and it will dump only that schema only. Object in belong to that specific schema. Now in pgdump, there are multiple. I mean, of course, I did not mention all the utility options here. There are options that in which format you want to dump that data. It could be a simple SQL format or maybe just a copy format. So in both cases, you can dump into a specific file. And of course, you can dump in the text file as well as the binary file. So there are multiple options available. So you can dump the schema. Of course, you can even dump the whole database that you want. Like for example, if there is a finance data, then there is a HR database, and you are interested in only to dump only one backup for a specific database, or maybe you want to have a frequent backups for a specific database. Maybe for finance department, you need a specific, the frequency of the data backup would be higher. So you can just dump that one database as well. Of course, you can also dump a single table using this pgdump utility. The question is, I mean, can you dump everything, whatever is there in the cluster? I mean, in one PG cluster, there could be multiple sub databases. And if you want to dump everything, including the schema, including the data, everything, you can use pgdump all utility. In that case, it will dump everything, including, of course, you have the choice, including the schema, including the data. It will dump into a specific file. Now, let's say you dump all those data. This is kind of logical representation, not the physical. It's not binary dependent. It's mostly text files. So once you dump the database in using the pgdump, you can restore it using the pg restore utilities. So PG restores is also a very important and built-in utility in PG. Of course, normally, of course, it is most of the time it is always installed on the same location. You have the other utility like psql, pgctl, and other utility. It's the same folder you will find this PG restore utility. And once you have the dump, you can restore a specific schema as well. I mean, of course, if you want to restore the whole dump, of course, you can do that. But if you want to reload a specific schema, you can do that as well. Another important option is that you can use the list option. Now, what it would do is, it will create a list, whatever is there in the dump. And later, even you can change those lists and you can use some custom list. Like for example, if you dump some database and it creates some list, you edit that list manually or maybe with using some system and create some custom list, and then you can just restore the custom object as well. I mean, of course, you need to take care of the dependencies and interdependencies between the objects so that the restore should not fail. But you can do the custom list and have the custom restore option as well. The good thing is about this logical backup is that they are portable. I mean, if you dump it, like for example, in one version, like if you dump it from PG 14 or 15, you can restore it in PG 16. Sometime, even a lot of time, this happen that some extensions, PG extension, which have their own data types or some other dependencies, library dependencies, and it is not possible to upgrade them. And then most of the time, what you can do is you dump them in some SQL format, and then you can reload into other major version. Okay, most of the time it is not an issue with the minor version, but for the major version upgrade, this is one of the challenging thing for the people who use a lot of extension, which where data is dependent on the extension. So you can use this. The good. This is the one of the major benefit that it is portable. It's a similar like what you see in high availability scenarios, the logical replication and the streaming replication. The logic replication, of course, you can use across different version, but the physical replication you cannot use into two different version. So portability is one of the main benefit. The other one is the granularity. I mean, you can see, you have seen in the previous slide, you can even restore one table, you can restore one single single table, single schema, single database. Even you have even option that you can edit the list yourself and maybe just delete something and just restore custom list. So the other that is only possible because it is human readable. That all the data which is dumped using pgdump and pgdump all is in text file. I mean, it's optional. You can use the binary and then compress it. But by default, of course, it is a SQL, standard SQL, and everybody can understand it, and of course, edit it as well. So the problem is that of course it's slower. Every single query will be executed again, and it will go through the whole execution cycle, and it will take some time. Of course, you can improve it using, if instead of using SQL format, you can use the copy format. It will make it a bit faster, and but of course, it's still slower. Another the concern is the potential data loss. You need to make sure that you actually took the backup of all the important thing, and which should be restored to make the application or the database in exactly the same state. The business logic should work with the after the restore option as well. So there is, I mean, because it's a human manual things involved, so you can maybe losing some data because maybe you did not took the backup properly. And for the large database, it's quite inefficient because I mean, it will take a lot of time. You will see in the RPO and RTO, I will show you in the later stage that it takes a lot of time to restore the logical backups. To take the physical backups, PG has a built-in utility which is base backup and PG base backup, which you actually took the snapshot of I mean current state of the system, and of course when it will take the snapshot of your current database system, it make sure all the integrity checks and all the inconsistency it will make sure that it is there. The other one major benefit PG-based backup is that incremental backup. Of course, I will. That is, I mean, going to be PG-17. I will in the last, at the end of this webinar, I will explain a bit about this incremental backup using the PG-based backup. Of course, I mean, different third-party utilities, they already have different kind of incremental backup functionalities, maybe in a different form, maybe incremental backup in the form of the file delta, which file are changed, which should be, the extra thing which are introduced after the last backup. They monitor the timestamp to do the incremental backup. So I will explain a bit more about this one at the end of the webinar. And of course, it is flexible. You can choose different table spaces or even individual file for the backup. And using the same PG, if you're, of course, most of you would be familiar with the high availability structure. And when you create the standbys, even the host standbys, code standbys, sync, async secondaries. First time most of the time you do is you create the first backup to create a new cluster using the PG-based backup. Okay, so it's kind of copy all the relevant file to a new location into your new cluster, and then it kind of reinitialize all those and populate your data. And even in case of the logical replication, recently you will see in PG-17 that before starting logical replication from standby, kind of cascade replication from the standby, first you can do what you can do is a physical using base backup. It will first create the first snapshot using base backup so that it should not take much time. And then after taking the first using backup using PG-based backup, then it will start the logical replication traffic. So of course, even in the logical backup scenario, it is used as a baseline. Of course, as a better has the command line tools, and you have so many options to customize it. Now, let's say you did created a backup, and I mean, no, most of the time previously, it happened is you took the backup using PG base backup, but how would you ensure that that backup is correct? Okay, so there is a utility in PG which is kind of built-in utility, which is PG verify backup. Okay, so if you create a backup and you want to make sure that this is a correct backup, there is nothing missing. Maybe during the backup some file is missing, some other issue with the file. So what the PG verify backup utility do is, for every backup, there is a backup manifest file. So first, it tried to read the backup manifest file, which has the metadata about how many files are there and what kind of data, what was the timeline. All those things are mentioned in the backup manifest. And let's say, of course, if there is a backup manifest is missing, PD verify will complain and throw an error that okay, you don't even have the backup manifest file. How can I verify, the other thing? So once it can read the backup manifest file, it has the list of all the things which it copied from the original cluster. So it can check all the files which are mentioned in the backup manifest. They are still available after the backup. And sorry. And of course, their permission is also correct, and of course, they are usable. And so the next thing is it can also check the integrity of those files. It will verify it will compute the checksum and verify that it match the actual checksum it has. And then of course it will verify all the WAL files are available. And if there are some issues with the backup, it will report errors that you can analyze and act on that. This is so far what we did is just create a snapshot from our existing database. But most of the time you also need, continuous archiving, the continuous backup. So how can we, and of course, when you have the continuous backup at the later stage, and maybe let's say some disaster actually happen, you have to recover as well. So which is point in time recovery, that for you want to recover your database to a specific point. So let's talk about the continuous archiving and point in time recovery. So, as I mentioned in the previous slide, that was PG-based backup. Actually, what it does is actually copy those WAL file. Now, what is WAL file? I mean, that is very important because this whole point-in-time recovery is mostly based on these PG WAL file. Okay, what WAL file is? Let's say if you have a user, of course, this is a system, and it can send a data to the, or maybe send a data store, or maybe update or delete, and it send a query, and ask the system, can you store this database, this data into the database? Now, PG and most, not only the Postgres database, in fact, most of the database, they have some kind of, some kind of mechanism to store the minimal thing, a minimum log, so that you can reproduce the same data again. So before going, the data is actually persisted into the disk. Every single data command, which is, it could be insert, update, or delete, or some other command, which is which can change the data. It is persisted into a log file, and we call them write ahead log file. So before, it is away ahead than the actual storage disk. So before going into the persistent data into the storage disk, a separate folder is maintained, and there are multiple files are created for to store those commands. And what these, most of these physical backups, they mostly rely on these WAL files. Okay. So how you actually do the continuous archiving? Of course, in PostgreSQL, there is a built-in functionality you can use. You all you have to do is turn on this archiving mode. You can set in the PostgreSQL configuration file, and then you have to mention one archive command. Okay, how would it actually archive that specific file? So PostgreSQL server will provide every individual WAL file to this and run this command. Of course, you see the %p and %f. So %p is the physical location of that file on your file system, and %f is actually the name of that file. So using this command, you can write your own command, and you can store these files to some safe location. Why? I mean, in PostgreSQL, I mean, you take all these logs and you store them. But of course, it will increase the size of your disk, the data directory where you are storing these WAL files. So to reduce that, once PG PostgreSQL has 100% surety that the data which is mentioned, or the command which are mentioned in this WAL file, they are persisted in the disk. Of course, it should be able to delete it. Okay, there is no point for the PostgreSQL database to retain them, because it will consume more storage. So you can mention, if some other utility want to use them or maybe store them, PostgreSQL provide this functionality that you can mention a archive command, and every time when PostgreSQL is ready to store that command, store that WAL file to some other location, it will run your this command. This one, by default, you will see most of the database has this simple copy command. Of course, you can have multiple, a quite complex command as well. Maybe let's say you want to store the data in some cloud environment, and you can put a simple, maybe Azure command, az some copy data to some specific remote location too. So this is command anybody can change and mention their own command where they feel that the data, the WAL file should be saved. And of course, in the restore command is used when you want to copy it back. So we will discuss the restore command later. So how actually it happened is that, for every WAL file, it has these multiple files. There is a special folder inside the PG WAL file. There is archive status. So once you have these, for every single wall file, there is this file which is initially it is like with extension dot ready, okay. And once it is ready, then there is a active process for the PG PostgreSQL archiver. As you know, PostgreSQL is a process-based architecture. So there is a dedicated process which name its name is archiver. So what it does, it that archiver process run that your archive command, and once that command returns successful status, then it can rename that file status as done. You see now all of those wall files are archived, so their status is now done. And after a specific time, PG will delete the wall file as well as its status file as well. Now, once you have these continuous archiving is functional and is working, your WAL file, which are quite important, they are properly, timely, they are, I mean, being copied to some remote location or maybe on some other day, some other media. And now you have the backup file. Now, let's say you have some disaster happen in this case, how would you want to recover that situation? So how, I mean, the simple restore for any backup, for the physical backup is like this, that you just create a one signal file. I mean, you should have a cluster, you just initialize an InnoDB and do a simple cluster. And you create a simple file, it's with the name recovery.signal file. As I mentioned earlier in the configuration as well, that restore command should be mentioned, that where exactly the data is that you want to copy back, your WAL file. Either it could be in, some local system, some, backup drive, some other location on the same system, or you can even mention some remote location as well. Like maybe you have some, cloud backup configured, and those cloud backup have some command. They provide you the command that you can copy file from storage, like for example S3 object storage. You want if there is a way that you can copy back some file, then you can mention in these restore commands. And of course, there are multiple as well command as well, that okay, let's say it is done with the restoration, everything is working fine. Should it delete now those commands, those wall file or not? So you can mention some cleanup script as well, and even the post restoration script as well, that should it send an email that okay, data is being copied, or maybe it should send a signal and mark some specific action that the restoration was successful, or maybe, of course, maybe if it is failed. So it should be able to notify the person who is running that restore operation. Now this is quite simple case where you just want to recover everything to the latest point, to the latest point, or whatever is available, the last wall file. Okay, so this is the simplest restoration. The PG provide a more, quite complex point in time recovery mechanism, and there are so many options. Okay, you can mention a specific restore point where until that point you want to restore your database. Maybe there is a specific time where you want to restore your database. Maybe still until some specific transaction you want to restore your database. Maybe some LSN, you mentioned some LSN, and I mean, until that WAL file, you want to restore your database, and maybe there are multiple timelines, and you choose one of the timeline which you think which timeline is the best, and it has the correct data, and you want to restore only that specific timeline. So the point in time recovery provides you so many options. I will explain all these options one by one. So the first one is, restore point when you need it. Okay. Of course, if you want to restore, if you see the third and fourth point, you have to create a restore point. And the last one is when you want to recover it, you have to mention that restore point. The question is when you should create a restore point. That can be done using manually by any DB can create it, or maybe some automatic system that can do it. Okay. And the point you should create when you have major schema change in your database server. And you may think, okay, after create making this critical, I mean, major change, you can be some unstable state. You should be creating um, uh, a restore point. Similarly, what you do, not only you manually, even in the operating system as well, like on the Windows, you create a restore point that, let's say you are doing something and it can affect your after the update or some installation, and you want to go back to same state, so you create a restore point. A similar concept is here in PostgreSQL database. You can create a restore point when you want to have a major database schema change. You want to load a large number of huge data, and it can fail in the middle, and it's risky and you cannot recover. Then of course you would be creating a restore point. Maybe you are upgrading your software, which can affect your database as well, so you create a restore point. These are the situation which are the major event. But of course you can have a regular interval that every week, every Monday, every Tuesday, every day, at the middle of the night, at the 4 a.m. most of the time you create a maybe of course you can create a backup as well at that time, as well as you can also create a restore point, so that later at the stage you can go back to the same restore and recover the database until that location. And of course, there are multiple other scenarios as well. If there is a potential issue in the hardware, you create the restore point. Let's say the management or the administrator notify that there would be a network outage, and then of course you can create a restore point. So the simple. So other than this, I mean, I'm not mentioning all the command for how actually you would do it. The rest of the procedure is same. You just create a recovery.signal file. You will update your restore, you will update the restore command, and then you will just restart the system and it will. But the only thing extra what you have to do is this recovery target name. There you can mention, your own restore point, and it will restore until that specific moment. The other thing is you can do the restore operation until a specific time. I mean, now how would you decide decide that time? I mean, that's up to you. You should know when was the time when everything was fine. So if you know that point, that okay, yesterday there was nothing happening, everything was fine. Okay, I should mention a date of yesterday until okay 4 p.m. everything was fine, but somehow in the evening something happened and something went wrong, or maybe you did the system upgrade and you remember that you did the system upgrade in the night, but in the daytime it was working perfectly fine. So you can mention a specific date and a time, and it will recover your database until that specific point. Another option is using the specific transaction. This is a bit tricky. I mean, how would you know that, how would you know the transaction which until that point you want to recover your database? I mean, if you have different monitoring system or some application which keep track of this transaction, and you can use this function, transaction ID current. So it will return the current transaction ID, and you save it somewhere on your application or somewhere that later point, if you want to revert to that transaction, you can do that. Now, this is maybe in the normal circumstances you don't need it, but let's say later you want to investigate it. You dump the file you using PG Vault dump, and you actually know until this transaction everything working fine, and then you can restore to that until that transaction. So it will recover your whole timeline, whole WAL files. It will repopulate and reapply all the WAL files and populates your database until that specific transaction is reached. Another one is every WAL file has a log sequence number. So now most of the time you do know which WAL file is correct, and until the last file, you know that okay, until this file, everything was fine. Even you can use the, let's say if the WAL file itself is corrupted, okay, and you use this pgdump utility to analyze all the WAL file which are available after a specific time. That's up to you what you want to analyze and see the summary that everything is working fine. So now let's say you find out that until this WAL file, everything was fine. Now that WAL file has a specific number, and you can mention in your target point as target LSN, and it will recover your database until that specific log file. And the last option is actually the timeline. I mean, someone asked the question, I will answer at the end as well. But I mean, in the next slide, I will also explain what are the timelines. That in the WAL file, it maintain a unique number, initial prefix that this is a unique number, and it is following this stream, and it is updating this. Okay, next file is this one. After that file, what should be the next file? Okay, that's one of the timeline, and you can mention a timeline using this target timeline option to recover a specific timeline. Now, what exactly is the timeline? Okay, you see, normally, if you have one database, it will start the timeline with zero. You see, in the start, there is a lot of zero, then there is a one, then there is a record first in the, then you took the backup, then you have the second in the, third in the, or something. Okay. And then let's say you took the backup and you want to restore to specific point. Then whenever you do a point in time recovery, it create a new timeline for you. Okay, maybe because that timeline would be divergent. Okay, one timeline is that 1, 2, 3, 4, 5, and at point number 2 you want to create a new timeline. Okay, so now it has a totally different timeline. It's like Git, like Git repository. When you have one branch and from a specific point, you create a new branch. So similarly, whenever you do a point in time recovery, you create a new branch. Okay. Not only in the point of time recovery, whenever you even create a standby and you promote it to be write only, instead of read only, it can accept and write data. Whenever you do that, it will create a new timeline for that one because now it is divergent. Okay, let's say if you have one database, primary database, it was doing something and it did the failover. Okay, and now you need to make a second database as a new primary. Okay, now it will create a totally, it know that it copied data from somewhere else, and that somewhere else was the first system, and its timeline was 1, so I should create a timeline from 2. Okay, so there are multiple scenarios which it create multiple timelines, and based on those timelines you can recover to a specific timeline that you remember that okay, this timeline was correct, there was something wrong in this specific situation, I have to recover just before that. Now you created a new timeline and you remember that okay, timeline number 3 was actually correct one, and you should whenever there is a, in the future you have to recover, you should recover to that specific timeline. For this physical backup, including the point in time recovery scenarios as well, the good thing is that they are faster. Okay, is this restore time is much faster than the logical backups, and there is a low risk of data corruption that I mean, because the system do it itself, and it has a lot of check and balances. It compute the checksum. It actually copy the whole file to the new location, so there is a very low risk of the data corruption, and it is quite efficient for the large databases as well. Okay, so there are some these are advantages, but of course there are some disadvantages as well, that you cannot do it, across the major versions. Let's say you have the PG 15 and you want to shift to PG 16, you cannot do this one. I mean, similarly, like what we do in the logical replication and physical replication. Physical replication cannot do replication across the major version. Similarly, for these backups, you cannot do the backup for the across multiple versions. So it's not portable, and of course it's not granular. As you see in the logical backup, you can even edit, and it's humanly readable. You can list all, you can see everything. You can list all those things. You can edit those lists and restore them at the table level, at the schema level, even at the table level as well. Even if you have a lot of insert command, you can even remove some data file, data from the dump, and of course it will not recover that, reload data as well. So you have the full control over there. But here you don't have that granular, in detail control over the backup. So it's kind of whole. It will restore the whole database or whole cluster. So these are mostly technical things, which are mostly the DBAs are, the architecture concerns. There are few, of course, there are management decision as well, which are in need to do. One of the major objective from the management side would be the, the RPO and the recovery point objective and the time objective. That, how frequent you should take the backup. Let's say some disaster actually happened, so you need to remember, that when was the last time you took the backup, and that was the, the stable state. Okay, maybe you took the backup, and even let's say disaster does not happen, you still want to find, when was the last time the system was stable, because okay, you observed some data corruption, you have to revert back to some point. Okay, you need to find the point where you need to revert back. So that the point where from the disaster backward in the time, when the last you have the last stable state, that is the recovery point objective. And let's say some disaster happen, and now you need to correct the situation. Okay, let's say management say, okay, system is down, you need to, respin it. Okay, restart it and recover everything. And what they will ask you is, how much time you need that the business is normal again. Okay, that time period from disaster to back to normal is your RTO. Okay, now in both, in logical and physical backup, in both situations there are different kind of RTOs and RPOs. Okay, because in the logical, if you see here in the first row, the first one is the RTO, and for the logicals, you need to schedule those logical backup command, because maybe you need to run, periodically, once in a month, of course you should, by the way, do it every day. I mean, if you are not doing it, then there's no point of, point in time recovery. And let's say if you are doing logical, and if your data is small, you would be doing it, every few minutes, maybe every day. And how, I mean, how much, why this RTU you can decide based on the size of the database. Let's say if you have a big database, it will take a lot of time to take the backup, and maybe you don't want to schedule it every 1 hour, because it will introduce some performance issues. Okay, so your logical, RTOs would be few minutes, could be in some days, or maybe you are creating through from standby, and you can reduce into from few minutes. Of course, in high availability system, even minutes, not only minutes, actually millisecond and second matter. That, how many second your actually the last backup was, or the restoration point is. And on the other side, for the physical backup, it depends on, when was the last, after the last backup, how much activities have to be done. And of course, it's also depend on the DB side. On the recovery point objective, like I mean, you have the RPO that, when did you took the last backup, So that's that's your own schedule, that, whenever you took the backup. And maybe let's say there is a situation that last backup was not correct. Then of course, in worst case scenario, you have to go back to one step, that where was your second last backup, and that you have to restore. Okay, and for the physical backup, of course, the RPO is that when was the last backup. I mean, if you have the continuous archiving, when was the last time that archive command was executed and you save that WAL file? Maybe it is 1 minute, maybe it is 1 second. Whenever it was ready and it was saved, that is your RPO. It could be, quite less. And of course, it's possible that, last WAL file, no, WAL file is saved. Okay. But the problem is, let's say that WAL file has corrupt data. Okay. I mean, if in the case of maybe some disaster where you actually lost the system, then maybe, but the system was stable at the point when it was actually some disaster happened. But let's say you did some wrong with actually your system, okay, and your data with human error, you fired some command and it actually corrupted the data. Now that corruption is inside the WAL file, and of course it can propagate to the standby as well. So the final thing you have only is your the WAL file, and you need to find out that what was the last correct WAL file when everything was fine. So in case of RPO, it would be the last WAL archiving time. But in worst case scenario, the second last one when everything was fine. So these are different RPOs and RTOs for logical and physical application. As a management decision, there is a rule of thumb that you should have at least minimum 3 replicas. Okay, and this is the rule is 3-to-1 backup rule, that you at least have 3 copies of your replicas. One should be primary, maybe you can have one standby, one could be hard standby. It's up to you how, and the configuration you are using, or high availability architecture you are using. So it should be more than 1 copy. It should be 3. And then there should be multiple storage medium, because if some specific event can disturb one kind of medium, of course it can disturb, if you're using the same medium, it can affect the second backup as well. So you can have a multiple medium for the backup. And of course, you should have 1 copy offsite. I mean, right now, these days instead of you can have a geo redundancy. You can create a copy in the cloud, and let's say some natural disaster happen in one location, you have the whole system and the data at some other location, which you can recover. Uh, Other thing is, of course, right now the storage medium is mostly cheap now. They are not as expensive as earlier. Few years back or maybe few decades back, they are quite expensive. But now they are less expensive. Of course, still expensive. They are less expensive. But and if you are using if your RPO is high and you are storing a lot of things, you are taking too many backup. They would be, it will even fill that storage as well. And main thing is you should save some space. Use the compression if you're using logical backups. Do DB. pgdump has it can compress into tar files, and for base backup as well, it can compress it also. There are multiple external ways that, external utilities you can use, or tools that can compress that file. I mean, you can consider, what should the compression level, the backup, how many backup you have to take, and any if there is any storage constraint or not. Because you see, if you are using compression, it will affect the restoration as well, because you need to uncompress them. No, the most of the compression algorithm which have high compression ratio, they have more time. They need more time to compress it and also to decompress it. And when you have the GBs or terabytes of data, compressing those files and restoring those files can take a lot of time. So you need to consider your RTO. Like for example, if increase the compression, it will take more time to restore. So your RTO can be disturbed using the compression level, and your storage space can be affected. How many backup you take. Every hour, every minute, every day, and even every day. I mean, some if there's a terabyte of petabyte of data, it every day can be a huge. Maybe every week is just enough to um, you know have that much data. Few things you need to configure, make sure that you don't do the configuration, you don't do the incorrect configuration. Like for example, let's say if you increase the shared IO buffer value, the IO with If it is incorrect, if it is too low, then of course it will do a lot of swap and there would be a lot of IO involved. And if it is too low, it means, maybe there is data is not properly saved on the disk, and it can be result into some instability. And of course, if there is no checkpoint, I mean, it will do, if it is low, there would be again frequent IO. If it is high, then it will quickly fill up the WAL file. And then you have to, configure your WAL location, that, wherever you are storing your WAL file or data file, it should have sufficient storage. And also the incorrect, you have to consider the permission on that specific area where the database system is either reading or writing the data. It should have sufficient permissions, so that database should not, throw an error silently and you don't even know that. How can, prevent that is other few other consideration is, never kill this, there is a concept like pull the plug test, and what you actually do is, you have the intentionally, like you see the like in the security domain, there are white hackers which actually do intentionally try to hack your system. So similarly for this database, there is a pull the plug test, that you actually shut down, certainly shut down your system to see actually what happened and whether you can recover from those situations or not. So in the routine, the DBAs and our management should schedule these kind of activities, that, in if something happen, certainly how to recover to that situation. And the other thing is, most of the database can handle and write the most of the file automatically. And whenever it change the files, it keep track of those files, it checksum and everything. And so we should not be doing, manual modification in the files, especially in the data file. In PostgreSQL, don't delete the PID file, because a lot of things are dependent on the postmaster page file. You need to take care about the antivirus software as well. So if you scan your database directory, it might delete some file, maybe find it malicious. Maybe the pattern of the binary form of a specific file is malicious, and it will delete the file. And even if, let's say, if it does not delete the file, most of the time antivirus, they take, they lock the file maybe, and it can do also do the have some performance impact in your database. So, be aware of the antiviruses, that whenever you install, you can exclude them from a specific antivirus, that it should not scan it. Of course, you should manage the permission of that data directly, that nobody else should be able to modify it. So nobody can corrupt them, but also you need to also take care of the antiviruses as well. And of course, never kill a process. Most of the time when you kill the process, it can corrupt your database. Whenever you do, actually, even shutdown, there are multiple ways, immediate shutdown, fast shutdown. So in all those situations, actually, it do all the necessary thing, and then maybe it has some data to write on the disk, it will write the data. It need to save some state, some update, some catalog entries, and write it on the disk, so it will. So if you do the kill -9, then of course it won't be able, it won't even have the time to do all those necessary things it should do. So never do the kill -9 on PostgreSQL any processes. Of course, there would be some situation where you really want to kill the process. Okay, like there is some process is locked, and what you can do is, there are other ways, like you can do the PG terminate backend, and of course it will terminate that specific backend. But of course, still it will do some cleanly, not like kill -9. There, I mean, I just mentioned most of these. This webinar is about the PG core concept, and mostly only I have covered is the internal, like, utilities. But of course, there are a lot of third-party application as well, like Barman, PG Backup, PG Admin, PG Pro Backup. So they have a lot of more functionality. For the enterprise customer, they would need that kind of flexibility for especially management. Like you have so many databases, how would you manage databases? How would you back up maybe 20 or 30 or 100 databases? You have to schedule different kind of interval for each database, different kind of with different setting, different configuration. You might need some integration. Let's say if we go to the, I just mentioned few features that, for example, does I just compare only few of them. Of course, this is maybe quite old data, maybe not 100% correct right now, but these kind of feature you do consider when you choose any backup tool, like whether it has better management, the CLI based or some integration with existing UI tool. Because if there are multiple database, it would be very hard to manage all those database. Then whether it can manage the WAL files, can it support the incremental backup or not? Because incremental would be more faster. Can it provide the compression so that you can save some space? Can it you can have multiple sessions that you can to do the parallel backup? Does it provide a remote backup? If you are setting the management administration utilities on a different machine, can you do the backup remotely or not? Can it provide the cloud integration that for geo redundancy, or maybe say storing the backup in some cloud? Does it have that functionality or not? And then of course, how many restore options are there which you can use? And of course, there are other like data validation as well. I mentioned a couple of them here. So these are different features you need to consider while using different tools. I will quickly go through this. This is an incremental backup feature which would be in PG17. Of course, it's not available, maybe not even production ready, but it's a nice thing which is going to happen in PG17. That you can do the incremental backup physical as well. That what you only do is in the wall summary, in the configuration, you turn on the wall summary. So you do is wall summary is equal to on, then what it will do is it will, after every the wall is created, it will create a summary of that wall file. And then you have multiple tools with that. For the PG, this new functionality for incremental backup, it has PG base backup in PG17 has new option for incremental backup, new flag. And to inspect that wall summary file, you have a new utility to do the wall summary. And let's say you have multiple incremental backups, you have to combine them. So there is a new utility to combine as well. Let's say, right now you have the first option like full backup, where you just PG base backup minus D, and you have one folder that you need to create this full backup. But let's say after that you want to have new backup, for only one day, and you mention minus D Monday, and then you use the manifest of the Sunday, last backup. So it will just store the new delta in this folder, not the whole backup. So only the thing which are updated, all the WAL files which are updated from this last point, it will only do the backup from that point. And of course, if you want from a new backup on Tuesday, you can use the manifest of the Monday previous day or any previous position. It's not a one day. You can you just need to whatever is here mentioned in the manifest file, it will take a backup after that point. Of course, right now it can create a lot of small data, backups, like, for every day, if you are creating one day, then there would be 365 backups. But let's say if you want to combine, kind of use what we do in database, which is aggregate. So you can do, aggregate as well. Like you combine the backup from Sunday, Monday, Tuesday, Wednesday, Thursday, Friday to Saturday to week one. Okay. And then even you can combine those backups into further into monthly basis as well. So this is how this would happen in the PG17, that we would be having this new big feature. How stable it would be, there would be of course bugs, but it need to go out and be tested from the industry, that to find out any issue.